This machine will amaze you with its power. A large amount of wood chips is thrown into this large cauldron, which spins continuously like it's cooking, handling as much as you put in. Eventually, all the wood chips will turn into small fragments and be transferred out from one side. By now, you must have understood, yes, this machine is used for shredding wood. It is called a unified wood shredder and is commonly found at on-site wood processing plants. The pieces of wood thrown in are all fragments without any usable value. To reduce transportation costs, workers will shred them on site to provide raw materials for paper production. At that point, the workers will control a mechanical arm to pick up the wood fragments nearby and throw them into the large cauldron. Notably, the wood is not shredded by the spinning cauldron itself, but by the roller shredder hidden at the bottom of the cauldron. The continuously spinning cauldron will push the wood fragments into the shredder. Here, the wood fragments will be crushed and ground, eventually falling onto the conveyor belt at the bottom and being transported out. As a common shredding machine, its work efficiency is very high, capable of shredding 1 ton of wood in an hour. Additionally, there is a type of machine for shredding branches. It resembles the large mouth of a beast. When fresh branches are fed in, numerous small fragments are spat out from one end and directly transferred into a nearby collection vehicle. Would you like to work with this machine? Can you withstand a strike with a force of 10 tons? When it hits the ground, it can make the soil sink a meter deep, creating numerous deep pits in the land. What are they doing? Actually, this is to prevent soil subsidence. You need to know that if the soil in this area is very soft, once an earthquake occurs, or the soil is compressed for a long time, the buildings on the soil will follow the subsidence, eventually leading to their collapse. To prevent this phenomenon from occurring, the soil needs to be compacted before building houses. This is similar to using a tamper to compact the soil, but it requires much stronger force. Therefore, this technique is also called dynamic compaction. The working principle is to use a crane to lift a heavy iron weight weighing from 10 to 40 tons to a height of 10 to 40 meters. Then release the iron chain or open it, allowing the iron weight to fall freely from the height and hit the ground. If one strike does not compact the soil sufficiently, the iron weight is lifted and dropped again. Typically, a spot will be struck 3 to 5 times, and the compaction depth can reach 6 meters. Although there are gaps between each pit, it does not affect the overall compaction effect because each time the iron weight strikes down, the force disperses in a conical shape downward, and the pressure between the pits overlaps, compacting the entire area of soil. Additionally, there is a type of vibrating compactor. It drives a vibrating drill into the ground, causing the surrounding soil to be squeezed to the sides, making the soil more compact. During the extraction process, a bulldozer beside it will fill the hole with gravel until it is filled. In this way, the area will form a load-bearing foundation, on which you can confidently build high-rise buildings.
This machine has the ability to dismantle concrete columns in just a few seconds. Placing the machine on the concrete column and then pulling it out forcefully, the once sturdy column will only leave behind a few steel bars. The dislodged concrete will be pushed aside. This is the miraculous hydraulic pile breaker, primarily used for dismantling concrete columns. When constructing buildings, these columns are embedded into the ground as part of the foundation. Due to their high hardness, dismantling them poses a challenging task. Hence, this hydraulic pile breaker was invented. The machine is suspended under the excavator's bucket and then placed directly onto the concrete column. If everything goes smoothly, the dismantling process can be completed in the blink of an eye. Even if there are obstacles, it only takes a few minutes. During this time, the hydraulic devices surrounding the pile breaker start to operate, pushing and compressing inward, much like driving nails into concrete columns and breaking them apart. At that point, lifting the pile breaker upwards allows the concrete to be easily removed. The entire process not only generates minimal noise, but also produces little dust, making it suitable for residential area dismantling. There are various versions of the machine, such as the one with a hydraulic cylinder ring. When placed on the column, this hydraulic ring applies strong pressure inward, gradually breaking the column apart. The whole process looks quite fascinating. Don't think that dismantling takes a long time. If done manually, it would take a whole day. Isn't this machine remarkable?
You won't believe how this old-fashioned hay collecting machine works so efficiently. A single production model tossed the blocks of hay on the ground into the rear trailer. This is the incredible old-fashioned hay collecting machine. Although it looks simple, it works with very high efficiency. As it travels along the blocks of hay, the forks attached to the ground wrap around the hay blocks. At that time, the driver will lift the hydraulic system in the cabin, which is connected to the collecting forks. In this way, the hay blocks are thrown into the rear trailer. However, because the equipment is too old, it often fails to throw or or wrap the hay properly. Moreover, there is a more advanced machine. By controlling the machine to align the intake with the hay blocks and driving through, the hay will be transported to the platform. Amazingly, the transported hay blocks are neatly arranged. When the platform is full, it will flip back, combining the layer of hay blocks with those in the rear trailer. Compared to the former, this machine can neatly collect the hay blocks. But there is a question. How do these grasses that originally grew in the fields turn into hay blocks? First, when the grass reaches maturity, the farmer will bring in a harvester. While retaining the roots, the machine cuts down all the grass. After 2 weeks of drying, the grass will completely turn into hay. At that time, many straight rows of hay will appear in the field. Then, a baler will arrive. Running along the rows of hay, the rolling device will roll the hay into the machine. Inside, the baler will gradually compress the hay and tie it with 2 thin strings. Finally, it will spit out the hay blocks from the back of the machine. The bottom of this ship has lifted out of the water, yet it can still move and its speed even increases. How is this possible? Firstly, this special type of vessel is called a hydrofoil boat. It has 2 hydrofoils, a triangular hydrofoil under the bow and a long hydrofoil under the stern. The principle is similar to that of a surfboard. By maintaining the hydrofoil at a certain angle and increasing speed, the boat can lift both the board and itself out of the water. Before starting, the hydrofoil boat will fold its hydrofoils into the water, then move using the water jet from the nozzle at the stern. During the initial period, it operates like a regular boat. When it reaches a certain speed, the lift generated by the hydrofoils will push the boat out of the water, creating a gap of about half a meter between the bottom of the boat and the water surface. This means the boat is no longer affected by waves, its speed increases, and passengers do not feel any bumpiness. The maximum speed can reach up to 114 kilometers in 1 hour. Additionally, there is a type of hydrofoil sailboat. This type has 3 hydrofoils on both sides and the stern. When the sea breeze hits the sails, it propels the boat forward, and the hydrofoils generate lift to raise the boat out of the water. Notably, when adjusting the direction to sail with the wind, sailors on both sides must quickly pedal to adjust the angle and height of the hydrofoils. The faster they pedal, the quicker the adjustments, and the smoother the boat will sail. What would you think about installing an anti-theft device like those in action movies? When a white fog fills the entire room within 10 seconds, it's not a fire suppression mist, but an anti-theft fog. Its purpose is to make thieves unable to see anything, thus protecting valuable assets. For example, as captured by surveillance cameras, when a thief uses improper methods to enter the room, the motion sensor combined with the mist sprayer will immediately trigger an alarm and activate the mist sprayer. The thief, already nervous, would flee even before the room is fully covered by the fog. This device has the significant advantage of being cost-effective and highly efficient. The fog sprayer consists only of water and half isopropanol. It is the isopropanol that makes the fog turn white. Before use, you just need to pour a mixture of water and isopropanol into the mist sprayer. The motion sensor should be installed on the ceiling, while the position of the mist sprayer can be adjusted. However, some timid thieves seeing the fog in this room might move to another room. Therefore, it is necessary to install multiple anti-theft fog units. Some people even add a flash, which will trigger along with the anti-theft fog. Tests show that each activation of the mist lasts for 15 minutes. If a thief waits for the fog to dissipate and then returns, the motion sensor will still trigger the alarm and continue spraying the anti-theft fog. Many large supermarkets and even ATMs have installed this device. What do you think about this device? This is the pinnacle moment for a technology enthusiast, as he has created an Iron Man suit that most closely resembles the effects seen in movies to date, earning him the title of the real-life Tony Stark from countless netizens. His name is Alex. Alex's creative journey has spanned nearly 6 years, and although he couldn't create a real ARC reactor, he crafted a hydrogen reactor as a substitute. Notably, this is also the only personal hydrogen reactor in the world today. With the presence of hydrogen, Alex can use plasma jets and hydrogen combustion tests to create the rechargers and cutters on the mechanical arms. In fact, research on this part took the longest time. Later, to have the limbs of the suit controlled by the reactor, Alex created an outer shell made of aluminum steel alloy with built-in electrostatic sensors. When detecting muscle movements, the pneumatic system controls the suit, and this pneumatics comes from the high-pressure hydrogen in the hydrogen reactor. Thus, it can be understood that Alex has done something similar to Stark, using an absolute core driver to control all parts of the suit. Currently, the suit is still being developed. Through 3D printing, combined with carbon fiber and electroplating technology, Alex is striving to make the suit lighter and harder. It is believed that the complete Iron Man suit will soon appear. Just for a cork, humans have extended their sinister hands to a 200-year-old oak tree, frenziedly chopping its trunk, stripping off its bark until the tree trunk is clean. You might think this is cruel, but the reality is different. This is a type of tree called cork oak, with soft, smooth, waterproof, and highly elastic bark, making it an excellent material for bottle corks. Some of the corks for famous wines are made from this bark, hence the cork oak is dubbed the guardian deity of wine. The production of a bottle cork seems simple, but is actually very complex. Because this tree is protected by law, its bark can only be harvested after 15 years of the tree's life. The second harvest must wait another 9 years, and the bark harvested after these 9 years is the best material for making corks. Therefore, to produce a quality cork, it takes up to 33 years. Despite bark stripping technology existing for centuries, craftsmen are always careful not to harm the tree's interior when stripping the bark. After the bark is removed, it needs to be air-dried outdoors for 1 to 2 years before processing begins. Then, workers soak the bark in water for an hour to boil and sterilize it, making the bark softer. Next, the bark is cut into long strips and pressed into cork shapes using special machines. The remaining materials are also not wasted. The factory grinds them into granules and uses them to make synthetic bottle corks. First, the granules are placed into a purification chamber for cleaning, then into a hot compression vessel where liquid CO2 is pumped in for a thorough wash, lasting 2.5 hours. Samples are taken and sent to the laboratory for testing to ensure no impurities remain. Next, the granules are mixed with glue and poured into molds, where a special molding machine shapes them into cork forms. They are then placed in an oven for 5 minutes to set. The loose granules now become flexible bottle corks. To facilitate easy insertion into the bottleneck, a lathe machine grinds the ends of the corks into angled tips. The factory uses cameras to inspect the corks for defects and takes samples to test for permeability. Subsequently, a laser engraver prints the distillery's brand information on one end of the cork and creates patterns on the surface to simulate the texture of natural cork. Finally, each cork undergoes individual quality inspection by quality control staff. Once confirmed to meet standards, these corks are sent to the distillery. Fastening your seatbelt when flying can save your life. What would happen if the aircraft door suddenly opened during a flight? This was a recent real-life incident on an Alaska Airlines flight. In mid-flight, the aircraft door unexpectedly fell off, causing nearby passengers to be sucked out, losing their clothes and personal belongings. Fortunately, the aircraft landed safely in the end, and the missing door was recovered. The incident did not result in any casualties. Many internet users have debated whether passengers would be sucked out if such an incident occurred at high altitudes. The reality is that without fastening your seatbelt, this could indeed happen. Even if not ejected, a strong rush of air could quickly enter, not only risking the aircraft's structural integrity, but also exposing occupants to low temperatures and lack of oxygen, potentially fatal conditions. It's worth noting that incidents where aircraft doors open during flight are extremely rare. This is due to the special design of aircraft doors, which require manual inward pulling and outward pushing to open. Furthermore, at cruising altitudes, the significant pressure differential between inside and outside keeps the door tightly sealed against the aircraft fuselage, making it nearly impossible to open even with considerable force. Therefore, such incidents of doors opening are only likely during low-altitude flight or during descent for landing. Passengers simply need to securely fasten their seatbelts to avoid being temporarily incapacitated due to oxygen deprivation and not be at risk of being ejected by airflow. This is the pinnacle moment for a technology enthusiast, as he has created an Iron Man suit that most closely resembles the effects seen in movies to date, earning him the title of the real-life Tony Stark from countless netizens. His name is Alex. Alex's creative journey has spanned nearly 6 years, and although he couldn't create a real ARC reactor, he crafted a hydrogen reactor as a substitute. Notably, this is also the only personal hydrogen reactor in the world today. With the presence of hydrogen, Alex can use plasma jets and hydrogen combustion tests to create the rechargers and cutters on the mechanical arms. In fact, research on this part took the longest time. Later, to have the limbs of the suit controlled by the reactor, Alex created an outer shell made of aluminum steel alloy with built-in electrostatic sensors. When detecting muscle movements, the pneumatic system controls the suit, and this pneumatics comes from the high-pressure hydrogen in the hydrogen reactor. Thus, it can be understood that Alex has done something similar to Stark, using an absolute core driver to control all parts of the suit. Currently, the suit is still being developed. Through 3D printing, combined with carbon fiber and electroplating technology, Alex is striving to make the suit lighter and harder. It is believed that the complete Iron Man suit will soon appear.